October 1962, the world faced the Caribbean crisis. In response to the Soviet missiles allocation in Cuba, the United States blocked the island of freedom. Tension among nuclear powers was growing. The Soviet strategic bombers were relocated to the borders closer to the targets in Europe and America. Exhausting combat watch began. Alert level was maximum. Nuclear bombs were suspended in bomb bays. Crew commanders received sealed envelopes with codes to charges and route maps with exact targets for each aircraft. The same was happening overseas. All involved in those days experienced enormous tension. Even incomplete knowledge of the nuclear weapons capabilities drew an astonishing picture of the aftermath. The world was on the verge of the Third World War. The climb to this peak of confrontation started right after the Second World War. Different understanding of the post-war development placed leaders of the former Allied countries at the opposite sides of the barricade. In March 1946, Winston Churchill pronounced his notorious words of the Iron Curtain, which started confrontation and the violently spinning arms race. The deliberate demonstration by the Americans of the atomic bomb's capabilities in Japan made the Soviet leadership to undertake urgent measures on the creation of both a similar weapon and means of its delivery. Enormous resources were thrown to the implementation of such programs. Development of the Soviet A-bomb was gaining momentum. Two variants were assumed for its delivery: aircraft and missiles. While in designing missiles, Soviet engineers were based on the German experience, creation of the nuclear weapons-carrying aircraft went in a different direction. In 1944, several American B-29 bombers made an emergency landing in the Soviet Far East. There were no such long-range bombers in the Soviet Union, so the decision was obvious. The aircraft should be copied. It was B-29 that dropped A-bombs on Hiroshima and Nagasaki. The task was assigned to Andrei Tupolev, who traditionally dealt with heavy bombers. The copy was called Tu-4. Timing was tough. The carrier was supposed to be ready by the time the Soviet A-bomb appears. The work started. No deviations from the original were allowed. Over 900 institutions and design bureaus were involved and new research organizations created. The aircraft was disassembled and drawings of each part were made. They amounted to over 40,000. Every single detail was copied, even a photo camera which was allegedly left by one of the American crew members. Creation of the aircraft significantly increased the level of the Soviet radio and tool engineering industries, gave an impulse to the development of new technologies and materials. The engines were not copied. Parameters of the engines designed by Arkady Shvetsov were close to the Americans. While B-29 had large caliber machine guns, Tu-4 was equipped with cannons. In September 1945, the Americans performed a long-range demonstrational flight of a group of B-29 from Hokkaido, Japan, to Chicago, Illinois. It was a message to Kremlin that the latter was within the nuclear bomber's range. Tupolev, as coordinator of all Tu-4 works, obtained most wide authority. In May 1947, less than within 2 years, the first machine piloted by Nikolai Rybko took off. In August, 3 new bombers were shown at the Tushino Air Parade. It was important for Stalin to demonstrate such aircraft to the potential enemy as soon as possible. Tu-4 was put in production at several factories even before the tests ended. Officially, the aircraft was passed into service in May 1949, but combat pilots started to master it much earlier. The first Tu-4 joined one of the Soviet Western air units. The aircraft was ready. What about the bomb? The first Soviet ground nuclear charge was tested in 1949. Improvements of the air bomb continued until 1951. On October 18, the first Soviet nuclear air bomb was dropped at Semipalatinsk. At a special aerodrome, the fully charged A-bomb is being loaded on the Tu-4 bomber. The bomb is suspended. The crew is ready for takeoff. The A-bomb carrying aircraft starts off on a combat mission. The aircraft approaches the target at an altitude of 8,000 meters. The bomb is dropped. Explosion. It was filmed from an altitude of 8,000 meters by a camera installed on the aircraft. However, Tu-4 did not become A-bomb mass carrier. Only 18 machines out of 800 produced were refurbished. Tu-4 had a range of only 5,100 kilometers, enough to reach Europe and the American bases in the Middle East and Japan. It could not reach the United States itself. From those bases, the enemy could reach practically any point of the Soviet Union. In 1948, the B-36 strategic bomber was made in the United States, representing even a greater threat. The Americans kept on demonstrating capabilities of their strategic aviation. In March 1949, the B-50 bomber performed a non-stop flight around the world. Tu-4, which fulfilled its task at the initial point of confrontation, required urgent replacement. In the end of the 40s, all Soviet directive documents contained the term range as priority. The jet aviation was performing its first shy steps, and designers attempted to squeeze the maximum range out of the piston aircraft by installing less consuming engines and additional fuel tanks. That's what the Americans did, making their B-50 on the basis of B-29. Tupolev followed the same path. Based on Tu-4, he first designed Tu-80 with a range of 7,000 kilometers and then Tu-85 with a range of 12,000 kilometers. But this was later. In the end of the 40s, the desired intercontinental range remained a stumbling block. But what about reaching America the shortest way, through the North Pole? This route was well mastered in the 30s, though it was difficult in terms of weather and navigation. Besides, there was also Canadian air defense to go through prior to reaching the United States. But still, the shortest route was interesting. New development of the Northern Theater of War started in 1948. Support stations, ice and onshore aerodromes were being developed. On the other side of the Arctic, the Americans were doing the same. Another solution of the problem was the in-flight refueling. First experiments of this kind were performed on Tu-4 and later, continuously updated, this system became widely used. The tasks of increasing the piston bomber's range were being gradually resolved. However, with the appearance of jet fighters in the end of the 40s, it became clear that a bomber would successfully overcome the enemy's air defense if it had speed similar to that of the interceptors. This was proved in 1951 in Korea when B-29 were completely defeated by the MiG-15 fighters. After that, both parties terminated their works on piston bombers and concentrated on jet aviation. However, characteristics of the first jet engines were disappointing. Miserable resource, insufficient thrust, unreliable performance, frustrating consumption. All this provided no optimism. Insufficient engine power was thought to be compensated by rocket boosters. As you can see, even such, the Il-22 experimental bomber was too heavy at takeoff. But evolution required transition to jet thrust. In December 1947, the Boeing B-47 medium strategic bomber made its first flight. Similar aircraft design started in the USSR. Creation of a jet aircraft required many non-traditional, almost revolutionary design methods. The new swept wing gave a significant speed increase. But such wing decreased the range and worsened takeoff and landing characteristics. Andrei Tupolev had to go through all those problems. On his way toward Tu-16, his team built an experimental 82 aircraft to master the swept wing. Several other projects were calculated. The last in the row, Aircraft 88, became the Tu-16 prototype. Sergei Ilyushin dealt with high-speed bombers. He once created a successful frontline Il-28 bomber. Therefore, for a new long-range bomber, the military command turned to him. Ilyushin did not take risks and developed the first variant, just like Il-28, with a straight wing. The aircraft was called Il-46. The straight-wing Il-46 performed its first flight in March 1952. 2 months thereafter, the swept-wing Tu-16 also took off. Ilyushin expedited works on the swept-wing Il-46, but time was lost. Tupolev already demonstrated characteristics that fascinated the customer. Proper engine selection played an important role in this process. Frankly, it is more difficult to create an engine than an aircraft. Normally, engine requires longer adjustment. The aircraft designer who puts the stake on the engine, which is at its last stage of adjustment, normally wins. Tupolev made a good guess with the engine for his aircraft. By February 1951, it became clear that Mikulin's AM-3 engine will be ready with a thrust higher than the initially planned. Such engine provided Tu-16 with a speed of 1,000 km per hour with full bomb load. In 1954, bombers were passed to the long-range aviation units. Soon, there appeared Tu-16A, the nuclear weapons carrier. Special attention was devoted to the layout and crew protection from thermal and radioactive emissions. The aircraft surface was covered with a special white thermo-resistant paint. Cabin glazing had special shutters. Still, after a complex nuclear impact, the lower light alloy plating could be pierced with a finger like cardboard. Tu-16A took part in 80% of all nuclear tests in the USSR. The Soviet Air Force obtained powerful means of destruction. The tasks, which used to require numerous air units, now could be performed by one crew. The power of just one nuclear bomb exceeds capacity of all 32 million bombs expended in the Great Patriotic War. The nuclear weapons jet carrier seemed to be ready, but the range still did not allow to reach America. The ever-growing military confrontation urged both the USSR and the USA to create a high-speed intercontinental aircraft. Overseas, this task was undertaken by several companies at once. Of all the projects, the Americans selected the B-52 Stratofortress of the Boeing Company. It had a wide-span swept wing. 8 engines provided the bomber with a speed of 950 kilometers per hour and a range of 12,000 kilometers. But B-52 did not reach such flight characteristics at once. The technical task of such an aircraft development is one of the most complicated. The bomber's prototype performed its first flight in April 1952, and only 3 years later, after numerous adjustments, this aircraft was passed on service for the U.S. Strategic Aviation Command. Since then, the Stratofortress has been on service, obtaining new capabilities from one modernization to another. Great Britain also developed a nuclear weapon-carrying aircraft. The British, being afraid of the Soviet military threat, discovered funding for even 3 bombers: Valiant, Vulcan, and Victor. In the Soviet Union, Vladimir Misichev was the first to initiate the high-speed intercontinental bomber construction. He promised the aircraft would have a range of no less than 12,000 kilometers. A governmental resolution on the bomber construction was issued in spring 1951. Only 2 years were given to carry out the task. On January 20, 1953, the crew of Fyodor Apache took the bomber into the sky. The aircraft had a bicycle landing gear, a flexible swept wing, pressurized cabins, and ejection seats. The percentage of novelties and therefore the risk was high. The bomber was equipped with 4 world most powerful at that time AM-3 engines, each creating a takeoff thrust of 9 tons. Tests were intense. Engines moped, new systems failed one after another, and the promised 12,000-kilometer range was not yet reached. The program faced termination with all further consequences. But let's get back to 1951, when Misichev obtained Stalin's okay for the creation of the unique aircraft. Tupolev, who always specialized in heavy aircraft, was first skeptical of the intercontinental jet bomber construction idea. He offered a project of his own. Tupolev preferred not to risk and did not include high extent of novelty. He even removed hydraulic actuators. He could not refuse using the well-tested propellers and made a stake on the Perspective turboprop engine designed by Nikolai Kuznetsov. Stalin decided to have a security in case Misichev fails and provided Tupolev with funds to build his aircraft. Moreover, with the turboprop engines, Tupolev guaranteed a range of 13,000 kilometers. Competition with both the Americans and each other was useful. Since the 30s, Andrei Tupolev was famous for organizing cooperation. This time again, he used his connections and authority in realization of his project and managed to retain a lot of contractors. In November 1952, 2 months prior to the Misichev's aircraft, the Tupolev's Tu-95 took off. But not everything went smooth. During one of the test flights, the first Tu-95 crashed. The lead went back to Misichev, who offered a number of measures to reach the required range. During works on the second M4 prototype, as the aircraft was called, a struggle against excessive weight was launched. A bonus was announced for each kilo of reasonable reduction. The landing gear was equipped with extension mechanism, significantly reducing the takeoff run. The aircraft passed tests within just 4 months. It reached a speed of 950 kilometers per hour and a range of 9,500 kilometers. This was less than the promised, but allowed to cross the ocean. For example, there are less than 8,000 kilometers from Moscow to Washington, D.C. The bomber was urgently commissioned, and on May 1, 1954, it flew over the Red Square. The same year, aircraft started to join air units. The new bomber produced enormous impression on pilots. Less than 10 years passed after the war. Pilots still remembered the old airplanes. Po-2 and Li-2 were still everywhere. And now this 180-ton beauty with a 50-meter wingspan capable of reaching the other continent. However, in result of continuous improvements, the two aircraft were now differing a lot from each other. This made the life of technicians and pilots more difficult. But nobody worried about that when the destiny of the country was at stake. M4 became the first in the world strategic jet bomber put on service. What about Tu-95? Works relating to adjustment of the aircraft and its engines required significantly more time. The second copy entered tests in February 1955. Capacity of its turboprop engines amounted to 12,000 horsepower. At tests, Tu-95 reached a range of 14,000 kilometers and was commissioned before the tests ended. It outlived its Misichev's competitor, and all that time its avionics, armament, and combat potential was continuously improving. In the 50s, the progress in aviation was unprecedented. But rocket industry developed even faster. We shall speak of the intercontinental ballistic missiles later. But there were other missiles, or cruise missiles as they were called. Indeed, with the continuous inability of the first-generation bombers to reach the required range, application of such means seemed to be the right solution. There was another reason. Supersonic interceptors and improved air defense left poor chances for the large aircraft to reach the target. With missiles, they could even not enter the air defense area, launching them from afar. But how to put missiles on a bomber? The first cruise missiles were rather bulky. Bombers had a narrow fuselage. In order to lower the drag, designers were reducing the cross-section at maximum. So missiles could be suspended only outside in a semi-recessed position under the fuselage or put on pylons under the wing. But this created additional drag. However, the total efficiency of such a system was higher than that of an ordinary bomber. Practically all commissioned long-range strategic bombers were tested as carriers of the cruise missile. The Tu-16 long-range bomber also became a missile carrier. In 1954, it was tested with a Comet, the first anti-ship cruise missile. The KH-20 missile was made specifically for strategic bombers. Tu-95 served this task most of all, identified in this variant as Tu-95K. Departing from the carrier, KH-20 could climb at an altitude of 15,000 meters and could fly for 500 kilometers at Mach 2. A similar system was made in the USA. The most successful was the Hound Dog missile installed on B-52. But let's get back to bombers. Having satisfied the military's thirst for the time being, with a rather raw M4, Misichev's team continued to improve the aircraft. Its new modification was called 3M. Some units were refurbished, the layout weight was reduced, the wing redesigned, and the more efficient and powerful engines were installed. With such improvement, all U.S. territory was now covered, including targets in the south, nuclear weapons centers, and launch pads in Florida. The aircraft was equipped with the in-flight refueling probe. Its first tests were performed on Tu-4, and since then the system was well mastered. It became the main means of extending the smashing sword of the long-range aviation. Tu-16 used a rather complicated wing-to-wing refueling system. The connected replenishment system was optimal for large aircraft. The more 3M bombers came to service, the more M4 were turned into flying tankers. Such giants could share 40 tons of fuel. One refueling increased the range from 12 to 15,000 kilometers. Soon, the Misichev Design Bureau introduced its 3MD missile carrier. However, the cruise missiles meant for it were not brought to perfection, and the system was left without the main component. Meanwhile, overseas, development of a supersonic bomber was started. It was B-58 Hustler. At Mach 2, it could fly 3,200 kilometers. Such minor range resulted from increased fuel consumption at a supersonic speed. However, the bomber needs such a speed only to overcome the air defense area. Its entire flight is performed at a subsonic speed, and the range remains quite acceptable. It is, of course, attractive to have an aircraft that could fly along at a supersonic speed. But there have been not many such aircraft in the entire history. One of them was the American XB-70 Valkyrie. Its development started in the 50s as an intercontinental bomber. Valkyrie was supposed to fly its entire flight at Mach 3. The project took a lot of time, and the aircraft took off only in 1964.
Green lights are out. Good.
America realized that it was too costly to maintain such bomber. Besides, the supersonic speed was no more a remedy from the air defense missiles. Valkyrie remained in the category of experiments. France also obtained an H-bomb carrier of its own. In 1959, the Dassault company launched its Mirage 4 supersonic bomber. The French considered it to be strategic, but with a range of 2,500 kilometers, the concept of its application was not clear. In the Soviet Union, strategic aircraft were those which had an intercontinental range. In 1954, Misichev obtained a new task, a supersonic bomber capable of covering 13,000 kilometers with a 5-ton H-bomb. Surprise! The subsonic M4 of this design bureau did not yet show the required range, and now a supersonic and super long-range project. In spite of the huge state support and attachment of hundreds of scientific organizations, the M50 project proved to be practically impossible. The perspective engines were not ready, while those available could hardly bring the aircraft to the speed of sound. Finally, M50 became a stand for testing new layouts and technological solutions. On July 9, 1961, a gigantic bomber streamed over the Tushino airdrome. The MiGs flying by underlined its dimensions. The hearts of the Soviet people were full of pride. It was in all respects a symbol of power for those unaware and the symbol of intentions that overrun capabilities for those who knew. It was the last M50's flight. The topic could have been continued with the M52 in mind, but the Misichev Design Bureau was closed. The first Soviet supersonic bomber was built by the Tupolev Design Bureau. It had more modest characteristics than M50. Its subsonic range was 5,800 kilometers, while supersonic range was 2,700 kilometers. This was already enough to carry a nuclear bomb to Europe. Initially, it was supposed to be based on Tu-16. However, drastically changed flight parameters gave the aircraft a completely new outlook. Two engines were put under the fuselage. The supersonic image was recognized by a thin, highly swept wing, long squeezed fuselage, and an all-movable tail. Its prototype was called the 105 aircraft. The aircraft was ready for flights in summer 1958. Like all new aircrafts, the 105 required long adjustment. A year later, 105A was issued, which accounted for the deficiencies of the previous machine. Finally, this particular aircraft became the prototype of the Tu-22 bomber, which was passed for service in the long-range aviation.
Здравствуйте, товарищи гвардейцы! Вольно!
For its specifically thin fuselage, Tu-22 was nicknamed Owl.
18 октября, московское время 16 часов. Я Протон, начало полетов.
Air units met the bomber cautiously. At supersonic speed, the aircraft was sometimes hard to control due to imperfect engine's location. Pilots were not happy with the high landing speed. The highly swept wing provides for the supersonic speed but does not allow to fly slow. This, by the way, made the in-flight refueling difficult. Downward ejection system did not give chances to survive at takeoff and landing. There were cases when crews refused to fly Tu-22. Despite the deficiencies, the bomber occupied its place in the Soviet Air Force. Several modifications were built on its base: a reconnaissance plane, a jammer, a trainer, and a missile carrier. The latter carried Kh-22 missile. As compared to other missiles, it was smaller, lighter, and faster. Its precision was up to 90%. It was already a full-fledged cruise missile. Progress in rocket industry led to appearance of intercontinental ballistic missiles. Precision was not yet perfect, but it was becoming better and better. Taking this into account, Nikita Khrushchev made a stake on this particular type of weapon. His plan envisaged enormous social reforms. Therefore, he decided to significantly reduce armed forces, including aviation. It is worth mentioning that in those days, aircraft could perform a nuclear attack faster than the missile. Although a ballistic missile could reach the target within half an hour, its pre-launch preparation took several days. Besides, launching pads were very vulnerable to retaliation. While aircraft could escape after the strike, change targets, or return back if the order is revoked. In autumn 1961, pilots were the ones who tested the most powerful weapon in the world. In the morning of October 30, a Tu-95 and a Tu-16 took off from one of the northern aerodromes. The first bomber carried a 50-megaton H-bomb. At 11:30 a.m., it was dropped near the Novaya Zemlya island. By the time of the blast, the aircraft were 50 kilometers away from the epicenter. Radio communication was interrupted for 40 minutes. Then aircraft were caught by the first blast wave, the second, and the third. The lightning was dazzling and long. The nuclear mushroom was 65 kilometers high and 95 kilometers in diameter. The explosion was detected by all seismic stations of the world. The blast waves circled the globe several times. Northern sea shores experienced seismic sea waves. With such a trump card, Khrushchev could now speak with America in a different way. A year later, tension reached its highest point, the Caribbean crisis. The world was approaching a deadly edge. Fortunately, politicians managed to find a way out. From that time on, the world changed. Before the crisis, the arms race was aimed at a real application of nuclear weapons. Now both parties understood that such application was impossible. However, improvement of both the nuclear weapons and the means of their delivery continued. The sense of euphoria in the Soviet Union did not last long. Development of the aircraft strike systems went on practically non-stop. Now real threat was coming from submarines with nuclear weapons on board. Therefore, while ballistic missiles were supposed to destroy enemy's facilities on its territory, aircraft were assigned to fight mobile targets at sea, submarines and aircraft carrying units. Tupolev, Sukhoi and Yakovlev introduced their bomber projects at a tender. The speed was supposed to be 2 or 3 times higher than the speed of sound. The winner was Pavel Sukhoi with his T-4 project. In documents, it was also identified as Product 100. Like M50, the 100 was a display of the most advanced technical ideas. Droop nose, fly-by-wire system, wide use of titanium alloys. All this allowed to reach a speed of 3,200 kilometers per hour. The first flight took place on August 22, 1972. The crew consisted of Vladimir Ilyushin and Nikolai Alferov. The 100 was supposed to make part of a strike reconnaissance complex together with the KH-45 missile. But the order for production did not come. The reasons were several: high project costs and interference of the powerful Tupolev, who did not want to give away his production site. Besides, T-4 did not respond to the new concept of a multi-mode aircraft. This idea occurred in the 60s and promised transition to a new quality level. It was assumed that by optimizing fuel consumption, aircraft could fly in a wide range of speed and altitude. The key to success was in the recently appeared novelty, the variable swept wing. Remember how many problems the swept wing brought to the Tu-22 pilots at landing. Now the aircraft could take off and land with a straight wing, while to increase the speed, it could vary the sweep. In spite of some technical complexity of such a wing, it was optimizing flight characteristics depending on their condition. The variable swept wing allows to use better aerodynamic characteristics at various flight regimes. Takeoff and landing are performed at 20 degrees. The subsonic flight is performed at 30 degrees. The supersonic flight is at 60 degrees. In 1967, Tupolev proposed to make a Tu-22 modification with a variable swept wing. He insisted that it was a modification and not a new aircraft. This was done on purpose. A modification takes less time and funding, which is always attractive for the customer. Of course, Tu-22M was a completely new aircraft. It was simply penetrated by the most advanced equipment of that time. All this expanded capabilities of the new combat complex, but significantly increased the time for the new systems and units adjustment. The main problem was, as usual, the engine. On the next Tu-22M2 version, they were improved, but it did not help much. The aircraft did not show the required characteristics in speed, first of all. However, this did not stop its commissioning. Things went better with the next Tu-22M3 modification. New engines were installed and the air intake's construction was changed. Now the power plant was by a quarter more powerful. Each engine in afterburning now had a thrust of 25 tons. The aiming and navigating complex, the automatic control and weapon control systems were all improved. Tu-22M3 was equipped with a jammer. Combat efficiency as compared to version 2 increased by more than twice. In the beginning of the 80s, the new complex was passed to the air units. It is still on service in the long-range aviation. The Tu-22M3 was equipped with different types of missiles. As a bomber, it could carry up to 24 tons of combat load. So far, we discussed bombers as nuclear weapon carriers, but apart from strategic tasks, long-range bombers can serve tactical purposes. For example, destruction of the enemy runway. The aircraft range could be increased with the help of the in-flight refueling. However, according to strategic arms limitation agreements signed between the USSR and the USA in 1976, refueling equipment had to be removed from all Tu-22M modification. The West feared such refueling capacity, which was putting the bomber into this strategic category. Its NATO identification, the backfire, was then in the headlines of all Western newspapers. Tu-22M was used in Afghanistan. Taking off from the Soviet territory, they bombed the Mujahid positions. It was then became clear that the bomber's capabilities were excessive for local tasks. The bomber was created for much more, for destruction of entire cities. As to the supersonic strategic aircraft, attempts to create it on both sides of the front never stopped. The United States were developing its B-1, the multi-mode bomber. Same works also started in the Soviet Union in 1967. The Sukhoi Design Bureau offered two projects. The revived Mesichev Design Bureau introduced a project of its own. The T-4MS project of Pavel Sukhoi was deemed the best. However, the Ministry of Aviation Industry and the Air Force ruled out that the aircraft development will be performed by Andrei Tupolev. Sukhoi and Mesichev had to forward all their materials to Tupolev. Thus, with the engineering ideas of all three teams, the future Tu-160 project appeared. Tu-160 was designed as a multi-mode strategic missile carrier. For the first time, such a heavy aircraft was equipped with a variable swept wing. With the wing sweep increase, there is a fence appearing from the first section flaps in the wing grooves, which serves for the wing's better lift-to-drag ratio in all flight regimes. According to NATO classification, Tu-160 was called the Black Jack. The Soviet pilots called it the White Swan. It had a wingspan of 55 meters and a takeoff weight of 275 tons, of which 170 tons represented fuel. Its range was 13,000 kilometers. It was armed with 12 Kh-55 missiles. Previously, missiles were simply suspended under the aircraft. Now they were put in a revolver launching unit. Cruise missiles were now more advanced. Though they fly at a subsonic speed, they do it at an extreme low altitude following the terrain. This makes them practically invulnerable. Their range has increased to 3,000 kilometers, like of a modern fighter. Production of 100 new missile carriers started in the Soviet Union, but in mid-80s funding was reduced and with the country's collapse ended completely. Only 30 machines were built. Prior to Tu-160, the strategic niche was occupied by Tu-95. Its modernization was continuous, but it got a second wind in the new Tu-95MS modification. It only looks like its predecessor, but its capabilities have significantly increased. New electronic equipment on board computers, powerful jamming support capable of distracting the most wise enemy's guidance system. The strategic bomber carries up to 16 Kh-55 cruise missiles. But with all the global technologies, for the first time since Tu-4, this machine was equipped with a toilet room. On all prior aircraft, with a range of up to 10 hours of flight, such a trifle was never given a thought. In the end of the 80s, the process of strategic weapons mutual reduction was started. Practically all Mesichev bombers, together with Tu-16, Tu-22 and early Tu-95 modifications, got under the ban. According to the agreement, Tu-95MS can carry no more than 6 cruise missiles. After the Soviet Union's collapse, a lot of bombers remained in the Ukraine and Belarusia. Under new conditions, these countries did not need any strategic aviation. Part of the bombers were passed over to Russia, the other part was scrapped. 100 B-1 strategic bombers were issued in the United States by that time. In the new geopolitical conditions, the Americans also started to count whether they needed such an expensive aircraft in such an amount. However, this did not stop them from making a new B-2 stealth bomber, the last tribute to the Cold War. Currently, Russia employs Tu-22M3 long-range bombers, Tu-95MS and Tu-160 strategic systems, as well as Il-78 air tankers. Tu-160 is by right the flagship of the Russian strategic aviation. Each is given its own name. One of the aircraft is called the Ilya Muromets, in honor of the first Russian bomber made almost 100 years ago. The history of the long-range aviation proves that together with the strategic missile forces and the nuclear submarine fleet, it makes an integral part of the country's defense system. Its potential is far from being exhausted. With the use of the high-precision weapons and the most advanced avionics, aircraft can fight not only with strength, but with skill. There has been not a single spot on the planet which they could not reach.